I press from 2.
Sorry?
What are you saying, sir?
I'm saying
I'm
making you the host.
Yes.
So that you can have a control of the class, then you can teach them from 2.
Yes, I'm aware.
Meanwhile, just stay in.
So what next now?
So you wait for. I've already allowed them to get in. Huh?
Yes.
So if you to preview, you can just start your lesson.
We start the lesson right away.
Yeah, at 2.
At 2 years.
I've done all the security checkups and everything.
Sorry?
I've done everything that is needed for the effectiveness of the lesson. So your work will just be to teach.
Yeah, okay, fine, thank you. Am I audible enough?
Yes, you're audible. I can hear you.
Okay, fine, thank you.
All right.
Yes. Good afternoon, everyone. So good afternoon, everyone. I will want to believe that all of you are faring on well, despite the challenge that we are going through as a country. However, that is how life has just presented to us. So we'll just take it the way it is. So welcome for the geography lesson today. I intend to take you through internal and forming processes, a topic that we have all learned in classes before we close school due to the pandemic. So this is a very simple topic, as we all know, as we all understood in our classes. And therefore, I will want to believe that me going through the topic will enable you to understand the topic better. So we need to ask ourselves some fundamental questions about the internal and forming processes. Where I come from and where all of us come from, because I want to believe that all of you are in your homes, we at times ask ourselves this question: why is it that where I come from is so hilly, while possibly a place like Nyanza is very flat, other places like Ukambani or Machakos, Kitui, Voi, going downwards is very flat. When you go to some places like Rift Valley, most of the places in Rift Valley are very mountainous. Some places in Muranga and many other places that I may not be knowing appears to be hilly. Now, these are an area that we will be answered by understanding the topic internal and forming processes. Now, I'll take you through some of the areas that we need that I feel like it is very important for us to understand. When we talk of land forming processes, these processes can be, sorry? These processes can either be external forces or internal forces. When I talk of the internal forces, I'm talking of the mountain building processes, earthquakes, volcanicity, and when I talk of the external forces, I'm referring to weathering and possibly erosion caused by water, air, or ice. But today, I intend to talk about the mountain building processes. That is the internal landform processes, or if you want to use the other term, endogenic processes. So as I alluded, we will stick to the endogenic processes, that is the internal landforming processes. Now, when we talk of the internal landforming processes, we are talking of forces from inside the earth and forces that are outside the earth. Now, when we talk of the internal landforming processes, we are talking of plate tectonics, we are talking of the volcanism, we are talking of seismic actions and many others. Now, let's begin with the types of earth movements. Now, when you talk of the types of earth movements, we are talking of the horizontal earth movement, and number two, the horizontal earth movement. Now, when you talk of the horizontal earth movement, we are talking of those forces that act along the surfaces. We are talking of those forces that act on the crust. Therefore, we refer to them as the horizontal earth movements. And when you talk of the vertical earth movement, I will take you back to what we learned in Form 1. That is the internal structure of the earth. We were talking of the sema, we were talking of the soil. Now from the crust, you move downwards. From the sema, from the soil, from the Morovisic discontinuity, the mantle, the upper mantle and the lower mantle. We talk of the Gutenberg discontinuity going downwards. You get to the outer core, then you go to the inner core now. Now, when we talk of the internal land forming processes under the vertical, under the type of earth movement under a vertical movement, I'm talking of those forces that act on the tangent. When I talk of the tangent, I'm talking of possibly in your imagination a cycle. Now in a cycle, possibly we have the edges. We have the outer part of the cycle. Now these forces, which we call vertical forces, are those forces that act from the interior of the earth, which I want to imagine that it could be the core, towards the outer part of the crust. So that is the two types of earth movements. Now, very fast, we will talk about the causes of earth movements. And we have 4 of them. One is we are talking of volcanicity. Now, when you talk of volcanicity, we are basically talking of, we are just trying to imagine. We have this mantle, we have this magma, and we said magma is the molten rock. Deep down there, possibly 1,000 kilometers or whichever kilometers it could be. And this magma wants to get to the surface of the earth. Now, when you want to get to the surface of the earth, this magma wants to get to the surface of the earth. Now, you'll ask yourself some questions. How will this magma get to the surface of the earth? Now, possibly it will try to create some cracks. Now, the cracks will be widened. And in the end, this magma will force its way to the surface. Now, when this magma try to find their way to the surface, possibly they'll be pushing parts of the earth's surface from either side so that it creates a path. Now, as this magma tries to find its way to the surface, it will be forcing its way, and thus it is able to create some kind of movement. This movement is the horizontal one, the horizontal earth movement, because it is pushing the sides. Possibly this is the channel, as you can see from the hand that you can see. Now this is in between here, is where the path of the magma, and this is the other side of the wall, and this is that side. Now when this magma tries to get to the surface, it is pushing. It is pushing the crust, and therefore this is what is referred to as the horizontal earth movement. Number 2 is isostatic adjustment. Now, when you talk of isostatic adjustment, we are talking of the balance that exists between the sema and the xyle, the sema and the xyle. Now, like today, I don't know where you come from, but I want to believe that all of us are at an equilibrium. We have a balance between the sema and the xyle. That is why we don't have an earthquake, we don't have anything like that. But I will want to tell you something here. When we have an imbalance between the oceanic crust and the continental crust, those terms, I think they're not new to you. So I'm talking of the oceanic crust and I'm talking of the continental crust. when we have the balance between the two, that point, we call it a point of isostasy. We have a balance between the simmer and the xyle. Now, when we have an imbalance between the two, the oceanic crust and the continental and the oceanic crust and the continental crust, that is when we will have some movements in the form of earthquakes, and that is what is referred to as an earth movement. Now, there are some questions that you could be asking yourself. How do you mean now? What do you mean now when you say we have a balance between the oceanic crust and the continental crust? Now, when we when we have the ice from the mountain melting, now what happens? We all understand that these ice are on the continental crust, possibly on top of a mountain or in some mid-latitude countries. Now, when this ice melts, what happens? The weight that was previously on the continental crust shifts, and these melt waters find their way into the ocean. That is what we refer to as the oceanic crust. Now, when we have the imbalance between the two, initially we had an equilibrium when the ice had not melted. Now we have the ice melting. Now the sea or the oceanic crust becomes denser, and the continental crust becomes lighter. Now, when we have that one, we will have a point of the isostasy. The equilibrium is messed up, and therefore we'll have an earth movement. Now, I'll still try to give another example of what we used to do while we were growing, the seesaw balance. Now, on the other side of the seesaw was your friend, possibly of your same weight. If you are 10 kg, the other one should have been 10 kg. That is when we have the equilibrium. Now, if the other side is a 20 kg and you yourself is a 15 kg, then possibly the seesaw will not balance. And that is the description that we are just trying to create in our minds when we talk of the isostatic adjustment. Isostatic adjustment. So as I was saying, when we have the same thing happening, the ice that is on the continents melts. This water will find their way into the ocean. We will have an isostatic adjustment. That adjustment will definitely cause an earth movement. We can also think it from this way. We have a drought that has lasted possibly, God forbid, for about 5 years, or even 2 years, for example, an extreme one. What will happen is, for example, the waters in the ocean will reduce because of the high heating and what have you. Therefore, the oceanic crust will be less dense, and therefore that equilibrium will be adjusted. That isostasy that we have said will be adjusted. Another one is when we have a heavy rainfall. I'm not surprised to get some news in some parts of the world that we have some earthquakes. From my understanding of geography, I expected because of the high rainfall that we have received this year. And what is happening now is we have the high levels of the sea waters, the waters in the oceans, the waters in the rivers, the waters in the seas, and many other water bodies are surging. And therefore, this kind of creates an imbalance in the isostasy. And therefore, we'll have some areas experiencing some isostatic adjustments. A minute, please. Those and many others which we learned in class, I believe will help us to understand causes of the earth movement. We also have the another factor, that is the magma movement. Yes, the magma movement, the convectional currents that happens in the interiors of the earth. When we have magma being heated, and we said magma is the molten rock. When we have this magma being heated, this rock being heated, then definitely it's like the water that we normally boil in our homes. When you put in your gas cookers and many other things that we use to warm or to cook, it starts to move in some currents. The same understanding we want to take to the magma. When magma is heated by the core or the mantle, which we say it can move as high, it can be as high as 5,500 degrees Celsius. That is very hot. Now, when these high temperatures that exist down the interior of the earth hits these rocks will begin to move in convectional currents. Now, these convectional currents will exert a frictional drag on the crust. Now, let's just try to create this imagination in our minds. You have your piece, your sufuria, and a piece of paper. Probably the one that will not sink. You put it on top of that water. Before you warm it, you will have the piece of paper will just be static. It will not be moving. Now start to warm. Begin. You warm this. You put in a hot surface. Time after time, you'll realize that the currents will be exerting a frictional drag on the piece of paper, and the piece of paper will appear to be moving. Now, that is the understanding that we want to bring into this concept of causes of earth movements. When this magma is moving in convectional currents, these currents exert a frictional drag on the crust, and therefore it will have some kind of an earth movement when this friction is exerted on the earth surface. Now, for us to understand this topic well, some theories has been given for us to understand. We have theories explaining the earth movements. We'll begin with one that is called the first theory is theory of the continental drifts, the continental drift theory. Now, this was an imagination, just like I'll ask you people to answer me this question. In your own imagination, your wild imagination, how do you think we have this earth movement? How can you explain that originally we had one Earth, that is what we know. How do you explain why we have South Africa where it is right, or South America where it is right now? Why we have Africa where we have it now? Why we have Europe where it is now? How can you explain such things? Now the same thing, the same question was asked by people have been just trying to find out why, what happened, and therefore many proponents of this theory. Now, the first one was what was brought up by Wegener, that is in 1912. But I want to tell you that it was not the original idea of Wegener. It was one that was propounded by Taylor in 1908, later in 1911. Barker tried to think alongside it, and in 1912, the person who appeared to have gotten a breakthrough is the Wegener. Now, it is important for us to know what really Wegener thought about the continental drift theory. It explains the origin of the 6 continents. Now, Wegener, in his book called The Origin of Continents, that was written in 1912, he appeared to believe that we had one supercontinent called Pangaea.
Yeah.
The supercontinent that Wegener thought about. And I'm challenging all of you to think of any theory that can explain the origin of the continents. Now, these continents, according to Wegener, said that this supercontinent called Pangaea was sitting on a huge ocean, I mean. The ocean was called Panthalassa. The superior continent, I'm talking of the Pangaea, the big one, was sitting on an ocean, a huge one. The ocean, according to Wegener, he called it Panthalassa. Due to gravitational forces, listen to this. I have said we had a supercontinent called Pangaea. This Pangaea was sitting on a huge ocean called Panthalassa. Now, due to the gravitational forces, this Pangaea, whichever way we want to call it, broke into 2. One in the northern hemisphere and another one in the southern hemisphere. The one that was in the northern hemisphere, he called it Eurasia. That was the one that was in the northern hemisphere. The one that was in the southern hemisphere, he called it Gondwanaland. It was in the southern hemisphere. Between the 2 continents that has been created out of the breaking of Pangaea, we had a sea, a small sea, separating the one continent that is in the northern hemisphere, that is the Eurasia, and the one that is in the southern hemisphere, that is Gondwanaland. In between the 2 new continents, the 2 one, we had a sea that is called Thetis. Further, due to the same thing, the same force acted on the 2 continents that has been created. The the gravitational forces, I mean, broke Eurasia into 2. One is the Laurentian Shield, that is the present day North America, and Fennoscandia. I have said Laurasia broke into two. One, Laurentian Shield, and number two, Phenoscandia. Laurentian Shield is the current North America. Phenoscandia is, Pheno was Europe, Scandia became Asia. That is why we have Pheno, Europe, Scandia, Asia. That is the Eurasia, the current Eurasia. So in essence, the three continents that we have today, North America, Europe, and Asia, broke from the parts that was in the Northern Hemisphere, that is the Laurasia. Gondwanaland broke into the other continents. It broke into one, Africa, that is one. Number two, Australia. Number three, South America. And number four, Antarctica. That is why we have the modern day 6 continents. Now you need to ask us questions. Are you convinced on what Regina said? Are you really convinced? The fact that he talked of Pangaea breaking into Laurasia, then we have Gondwanaland. Now Gondwanaland breaking into 3, that is Africa, South America, Australia, Antarctica, yes. And Laurasian breaking into North America, Europe, and Asia. Are you really convinced of those wild imaginations? Now, because he understood that we could be in a dilemma that we are all in at the moment, he gave evidences to support his theory. The first evidence is evidences supporting the continental drift. The first evidence is the jigsaw fits of continents. I really wish that some of you could be having atlas maps. Now open a page that has the world maps, that is the Africa, all in one page. Can we see that? Yes. Now, try to bring all the continents into one point. You will be surprised to see, especially the African continent and North American continent and the South American continent. They fit perfectly. The West African side of Africa fits into that area around Brazil, the Mexican curve. It fits perfectly as though it was separated some time back. So this was one of the evidences that also kind of makes me feel like Regina knew what he was talking about. And that is why I'm a big student of continental drift theory, because to me that one appears it makes a lot of sense to me. The fitting of the continents, especially the African continent and South American and the North American, it fits kabisa kabisa. Yes. Number two, we have the paleontological evidence. Now, Regina seemed to have traveled into so many countries. He traveled to Africa, that is the South Africa. He also went to Brazil. And if you check from your atlases, you'll find that they are almost on the same level. That is Brazil and Africa. Now he went to Brazil, someplace in Brazil, and he found remains of an animal that is called Mesosaurus. He also came to Africa, and specifically South Africa. He also found remains of the same Mesosaurus. He found the remains of the Mosasaurus in the South African continent, that is around Brazil. He also came to Africa. He found the same remains of Mosasaurus in Africa. And one thing that you need to know about this animal called Mosasaurus is this is a reptile. It is a reptile, by the way. This is a reptile that survives on shallow fresh water lakes. It is an animal that only survives in very shallow that survives on very shallow freshwater lakes. Now help me understand this. We have a reptile that is found in Brazil. We also have one that is found in South Africa. There are two possibilities. Possibly the Mosasaurus flew all the way from Africa to South America. I've tried finding out if the Mosasaurus had the ability to fly, but I found out that it was not able to fly. Now that possibility is ruled out. The other possibility is these Mosasaurus swam all the way from Africa through the Atlantic into Brazil. That is a possibility. From South Africa, where Wegener found it, it swam all the way. Look at him. Moses Carissa, what are you doing? Yes, Moses. Yes, can you be attentive? I was talking of the possibility of the Mosasaurus flying all the way from Africa to Egypt, and we have ruled out that. We also have the other possibility, the Mosasaurus reptile swimming all the way from Africa to Brazil. Now, the other thing that we need to know is Mosasaurus only survives in a freshwater lake. All of us have been to the coast and we've tested the waters of the Indian Ocean. And if you're lucky enough, I think you've been to Atlantic and you've also tested the waters of the Atlantic. And we are in an agreement that all the waters of the oceans are salty or they are saline in nature. And therefore, these Mosasaurus could not have really survived in a saline situation. Then therefore, it rules also that possibility. Now, the possibility that remains is before the drifting of the continents, possibly some section of the Mosasaurus had gone to the other side, to the eastern side, and the other was on the western side. And when the drifting occurred, those ones that were on the east, zilibaki to the east, that is Africa. When you walikuwa wameenda west, wakaenda na they went with the plate that was west, that was drifting westwards. So that is, I think I've really tried to explain that evidence. Number 3 is in Africa, it has been found that it has glacial deposits. It has glacial deposits. Now you are in Africa and you want to create an impression that we have a glacier in Africa. I think that is not really possible because Africa as a continent is within the tropics, and therefore the existence of glacial deposits. That is, when you talk of glacial, we are talking of glaciers. We are talking of ice. Deposits of ice movement. It has been found that it is somewhere in Ethiopia. Now help me understand this. Glacial deposits found in Ethiopia, Africa, a region that is within the tropics. Now, how best can we explain this? Now, this is a possibility. Probably Africa, before drifting, was either to the north, in the northern hemisphere, in the mid latitude, that is the 60s, and we had those deposits being formed. Then after drifting, after the formation of those glacial deposits, Africa drifted southwards, or if it was in the Antarctica region, it drifted northwards. Hope I'm making some sense here. Yes. Then we also have another evidence that talks of the formation of coal. In his studies, that is Wegener found out that we have the existence of coal in Antarctica. Now you need to know this. Coal as a mineral only forms, listen to me carefully. It only forms in warm tropical climates. Coal as a mineral only forms, Lenson. I have said coal as a mineral only forms in warm tropical climates. Now, how can you explain the existence of a mineral that only forms in a warm tropical climate in Antarctica? How can you explain that? Any idea? Philip? Any idea?
No.
No idea. Lenson, do you have any idea?
No.
Just give a try. Okay, fine, I'll help you this. Now I have said coal is a mineral that Wegener found out to be in existence, and in fact in abundance in Antarctica, and yes, Antarctica. Now there is the only possibility that you can really try to bring out is coal after it was formed, that is Antarctica. Possibly it was in the tropical regions, that is between the 30 and going downward, 0 to 30, that is the tropicals. And after being formed, the Antarctican continent drifted southwards. The Antarctican continent drifted southwards. Therefore, it now explains that the existence of coal in Antarctica. It formed when it was in the latitude, the tropical climates, and therefore it drifted after the formation. That explains why we have coal in Antarctica. Now, enough of that. Let's go to the other theory. We only have two theories. We have the plates tectonics theory and the one that we have just discussed it, the continental drift theory. Now, the plate tectonic theory states that the crust is made up of rigid blocks, the earth crust. I know you know what I mean when I talk of the earth crust. The earth crust is made up of blocks. These blocks are called plates. We have larger plates and we also have the smaller plates. The larger one include the Eurasian plate, we have the Australian plate, we have the African plate, we have the Antarctic plate, we have the North America plate, we have the South American plate, we have the Pacific plate. Those are the larger ones. We also have the smaller plates, and they include, there are a bigger number, there are 9. We have the Indian plate, we have the Somali plate, we have the Caribbean plate, we have the Philippine plate, we have the Scotia plate, we have the Nazca plate, and many others. Now it is important for you to listen to this. We have the smaller plates. You can give examples 2 or 3. African plate, Antarctic plate, Pacific plate, American plates. Just give any 2. Then number 2, we have the smaller plates. You can name 2. Somali plate, we have the Nazca plate, we have the Arabic plate, we have the Indian plate. Now these 2 plates, either the smaller or the bigger plates, they are sitting on a molten magma layer. The plates, the rigid blocks that are called the plates, are sitting on, they are floating on molten mantle layer called a asthenosphere. These rigid plates, the African plate, the Somali plate, the Nazca plate, the Antarctican plate, they are sitting on an oceanic plate. They are sitting on a molten mantle called a asthenosphere. Now these plates, they move because of the asthenosphere. They move in the convectional currents. The plates move relative to each other due to the convectional currents in the mantle. I've explained the convectional currents while we were talking of when we were talking about the movement, the causes of movement, and under the convectional plates. And as a result of these rigid blocks are sitting on this molten magma that is called a asthenosphere, they either move towards each other, away from each other, or past each other. Lenson, I remember teaching you this. Remember it? You can unmute and respond.
Yes.
Okay, thank you. Now these plates, they either move towards each other, away from each other, or past each other. We will understand this in a short while. Now, when they move towards each other, now we have one plate, either the oceanic plate or the continental plate, moving towards each other. Where they meet, the 2 plates meet, will have some destructions, right? Some materials will be destroyed when these 2 plates meet as they come towards each other. And they will be destroyed. And therefore, it takes the term destructive boundary. That boundary that exists in between the 2 plates coming together, coming towards each other, a boundary that is called destructive boundary is formed. It is called destructive because some materials are crushed, destroyed. The plates themselves, the plates that were coming towards each other, they will be destroyed, they will be crushed, not completely destroyed, but some part of it will be crushed. And therefore, we call it destructive boundary. And because the plates were coming towards each other, it is also called compressional boundary. What are the effects? What are the effects? We have one plate, either the ocean coming towards each other. What happens? There is a subduction, or the sea flow is pulled inwards. That impact, when we have two plates coming into contact, one of it, which is the less denser, will go underneath, and we'll have a trench we'll have a subduction area. The sea flow is pulled inwards. That is what is referred to as the subduction zone. Another possibility is sediments on the seafloor. We have two oceanic plates coming towards each other. The sediments in the seafloor, they can be compressed to form fold mountains. So there is two possibilities. Two plates coming, and we have the sediments being pushed and they form the fold mountains, or we have a subduction or ocean flow being pulled inwards. So those are the two possibilities. And I've said there is three possibilities. I've said the first one is when the plates come towards each other, and the other possibility is when plates move away from each other. We have one plate moving away from the other one. We have the African plate moving from the North American plate or the South American plate. What happens? Possibly we'll have the extension of the ocean. We have the ocean trenches. We will have, we'll have the ocean trenches. We'll have whereby the ocean is extended because one plate is moving away from each other. So in between, it is filled by the water. It is filled by the water. The other possibility is when the plates move towards each other. By the before I get to that, the third one, I've said when plates move towards each other, we have new things being constructed. We have new features being constructed. That is why we call it constructive boundary. When the first one, when plates were moving towards each other, new features were being destroyed. That was why we referred it to destructive boundary. But now this one, we have new features being formed. So that is why we give it the word constructive boundary, because new features are being created. New features are being created. So that is why we call it constructive boundary. The last one is when plates move towards past each other. They form a boundary that is called transform boundary. We have a boundary that is called transform boundary. Now, transform boundary is where we have one place moving past each other. In essence, none of the places are destroyed. The other place move, ikipita hiyo kando ingine napita hiyo kando ingine. So nothing is destroyed, nothing is created. So that is why we call it conservative. It conserves the thing that existed. And the only feature that can form there is a tremor, an earth tremor, or a major fault. Not it is a minor fault, like the San Andreas that exist in the in Northern America. Now, what are the significance of plate movements? Now, this plate movement results to earthquakes and even volcanicity. We talked of the constructive boundary where the plates were moving away from each other. We had magma, new materials coming out of the interior of the earth and forming new features. That is volcanicity. When we have plates moving past each other, we have the earthquakes. With the impact, when the two plates moves past each other, that impact, it creates an earthquake. It also leads to the formation of landforms such as ocean trenches and even the fault mountains. It causes formation of landforms, spectacular landscapes formed, leading to tourist attraction sites. Now, let's take a few minutes to go through what we have learned before we move to the next part, that is folding. We've talked of earth movements, and we said they are of two types. One is the horizontal earth movement and the vertical earth movement. We've also talked of the causes of earth movements, among them convectional, magma movement, isostatic adjustments. We've also talked of the theories that explains the movement, the type of movements. And we've talked of the continental drift theory, where it was propounded by Wilson in 1912, and it was an advancement of what two other people had thought about, that is Taylor of 1908 and Becker of 1911, where he said we had one bigger continent called Pangaea. Pangaea drifted into Laurasia in the northern hemisphere and Gondwanaland in the southern hemisphere. Then the Laurasian drifted into two other major continents, that is North America and Eurasia. That is Laurentian Shield and Fennoscandia. That is the Laurasia. And Gondwanaland broke into four. That is Africa, Australia, South America, and even Antarctica. Yes. Now we've given the theories that supports the continental drift theory, which I want to believe that it was just an emphasis of what we had already learned in class. And the other theory that we've talked about is the plate tectonics. We have talked of bigger plates and we have the smaller plates. There is this possibility that it can be asked in your examination. You'll be opening school next year, God willing, January. And we can ask you a very simple question. Give 2 examples of smaller plates. Give 3 examples of bigger plates. And we will get most of you off guard. You'll be thinking of giving us the major continents, which you will get it wrong. So you need to be knowing examples of those continents, either the bigger ones, the bigger plates, and the smaller plates. Now, of great importance, Gerald Muroki, I can see you are enjoying yourself. As you also need to know that these plates, either smaller plates or the bigger plates, they are divided into two. Either they could be the oceanic plate or the continental plate. These plates, the two, oceanic plates and the continental plates, can move away from each other. It can move towards each other. It can also move past each other. When we have these movements, it creates some boundaries. Which boundary is formed when we have plates moving away from each other? Gerald? Which plates? I can see you're opening a book. Which boundary is formed when we have plates moving away from each other?
Constructive.
Yes, constructive boundary. Vincent Kinywa?
Constructive.
Constructive, right? Yes. Which plate is formed when we have plates moving past each other?
Conservative boundary.
Yes, conservative boundary. Yes, that is good of us.
Transform.
Yes, the last one is the transform. That is good of us. Those are the small questions that we'll ask you in your exams. And once you have those ones, it is good, you are good to go. Now, the next one is folding. Well, on duty on many occasions, many a times, I've met students reading some funny things. And immediately when they see the teacher, they fold their papers. In essence, that is what we are talking about. We are talking of that, you folding that piece of paper. What do you do when you fold your paper? You know what you are doing. Now, when you talk of folding, and in respect to earth movement, we are talking of a process where the crustal rock are distorted by compressional forces being caused by upward and downward bends. Now, because of the compressional forces, you compress that piece of paper that you don't want to see, you don't want the teacher to see. You compress that piece of paper, and it will have upwards and it will have downwards. Now, imagine a situation that where you are given earth and you need to fold it. You will have one end sinking or bending downwards, and you will have the other side bending upwards. The bend that the one that bends upwards are the anticline. The one that bends inwards are
incline.
Yes. When you bend, there is always a line that it was almost breaking. If you continue to have compressed it further, then it could have broken. That line of weakness is what is referred to as the axis. I know you have the imagination of what I'm trying to bring, the parts of a fold, which we did in class. It can really be a challenge, especially with Zoom, because you need to be able to draw. But nonetheless, these are things that we have learned in class. And I'm just trying to direct you on what is very important for you to get. It's very possible, and I saw it in the 2017 KCSE. They were asked a very simple question. With an aid of a diagram, draw and label parts of a fold. And it had the 4 marks. Those are free marks. You need to know where the anticline is. You need to know where the crest is. You need to know where the trough is. You need to know where the syncline is. You need to know where the limb is. And you also need to know where the axis is. Those are free marks. But if anyone decides to test you, you should put those 4 or 5 marks very safe with you. Now the anticlines, these are the parts of the earth surface which bends upwards. Those are the upfolds. When you talk of the synclines, basically we are talking of the downfolds, the crest. This is the uppermost part of the anticline. This is the uppermost part of the anticline. We have the anticline in general, but the uppermost part of the anticline is what is referred to as the crest. The lowest part of the syncline is wide, yes, the whole trough is. Now we have the lowest part. It is what is referred to as the syncline. The limb. These are the rock layers sloping on both sides of the fold. Both sides will have the limb dipping into the forces. The axis, this is the imaginary line drawn vertically through the center of the anticline. Now we have the types of folds. I remember these are normally frameworks which are given to you. I remember you sitting for an exam that required you to give types of folds. The first one is the symmetrical fold. The first one is the symmetrical, where the limbs dip along symmetrical lines. So the limbs dip in almost an equal manner. The opposite of that is the asymmetrical. I will go through this very fast because you already have them. Asymmetrical. The limb, one limb is steeper than the other one.
Sure,
That is why it is called asymmetrical. Asymmetrical. One limb is steeper than the other one. And it is caused by compressional forces of unequal magnitude. We have compressional forces, possibly on the other side was weaker one, while the other one on the other side was stronger, which results to limbs being asymmetrical, one being steeper than the other one. Number 3 is the overfolds. This is when the anticline of one fold is pushed over the limb of the other one. In essence, we have enormous compressional forces acting on one fold and pushes it completely over the other limb. Now, isoclinals, these are close limbs almost parallel to each other. Now, this is when the compressional forces are of equal magnitude. Now, I will take a short time to talk about the anticlinoriums and the synclinorium complex because I saw it in a very serious exam. I think it was 2018 KCC examination, and it had about 7 marks. The question said, with an aid of a diagram, explain how synclinoriums and anticlinoriums are formed. What do you think? What is your perception on how on the formation of synclinoriums and anticlinoriums? Now, synclinoriums or anticlinoriums are formed initially when we have a minor, a very weak compressional forces acting on a piece of land, a very weak one. The result of this is we'll have very small synclinoriums and anticlinoriums, and many of them will have a kind of a wave. This one, a wave. These small synclinoriums and anticlinoriums were formed when we had this piece of land being subjected to very weak compressional forces. And the compressional forces acted on that piece of land and it stopped for a while. After some time, the same piece of land that had been acted by the weak compressional forces is acted by compressional forces of bigger magnitude this time round. The same piece of land with very minor faults and upfolds, the synclinoriums and the anticlinoriums, the small ones, is acted by compressional forces, this time of bigger magnitude. Now we will have bigger falls and bigger bigger synclines and anticlines, and in anticlines and the synclines, there is someone who is disturbing us. Yes, thank you. So I've said we have an anticline and a syncline. On it, it has several, it has a lot of small upwards, upfolds and downfolds. It has the synclines and the anticlines on top of the bigger syncline and the anticline. That is why we call it anticlinorium and synclinorium complex. So enough of that. Let's go to the features. Features that are formed due to folding. After folding, after the synclinoriums, after the symmetrical, the symmetrical, and many of them, those ones that we have said. What are the features that are formed? One of them is the one that we've really talked about, is the formation of fold mountains. Again, the idea of the formation of fold mountains appears to be all complex thing. And therefore, whenever we have a thing that it appears to be complex, like the origin of the continents, the origin of the solar system, of course, we saw there's so many theories, the nebular cloud theory, we had the passing star theory, to try to unravel to us what seemed to have appeared that we may not be knowing. Again, the formation of fold mountains is something that has really brought problems, and therefore we've had theories that just try to explain the formation of mountains, fold mountains. The first one is the contraction theory. Number two is the convectional current theory. And we also have the continental drift theory. And finally, we have the plate tectonic theory. All the four theories tries to explain the formation of fold mountains. Let's talk about the first one, contraction theory. Now, according to the first theory, it states that during the Earth's formation, surface rocks cool faster and wrinkled to form fall mountains. Now, this theory appears to have borrowed much on the nebula cloud theory, or even the passing star theory, whereby the original materials as this unique star drew material from the sun. The materials were very hot. And these rock, the materials that were drawn from the sun, some materials cool faster and wrinkled. You know, you can have an imagination whereby we have some hot materials maybe in a polythene bag. You can put an ice. You put some water in an ice, and then you put it in a freezer, for example. Now, what happens is you will have some materials cooling very fast, and it will form some wrinkles. These wrinkles, to these proponents of this theory, it seemed to have made their minds to believe that fall mountains were formed as a result of contraction theory. The original materials during the Earth formation, they cooled very fast, wrinkled to form fall mountains. It appears fake, appears vague, but I think that is what they thought of. Now, number two is convectional current theory. Now, this borrows much on the convectional currents. Now, inside, we have the mantle, which is very hot. It is about 5,500 degrees Celsius. It hits the rocks down there, and the rocks melt. Now, these rocks move in convectional currents. These convectional currents in the mantle exert frictional drag on the crustal rocks. The convectional currents in the mantle exerted frictional pull on the crustal rocks. The continental crust were pulled towards each other. Sediments between them were squeezed into falls. Am I clear? I've said horizontal convectional currents in the mantle exerted frictional pull on crustal rocks. Continental crust were pulled towards each other. Now, the sediments that were hanging in between, they were squeezed because they are young rocks, they are young soils. They can be squeezed anyhowly. And these sediments that existed between the two continents, they were squeezed to form falls. I think we'll be meeting this theory a little from a few minutes to come. Number three is continental drift theory. And this theory suggests that during the breaking of the Gondwana land, India drifted northwards and collided with Eurasia. Sediments between the two continents, that is between India and Eurasia, those sediments, they were squeezed to form mountains. And examples of such mountains are the Himalayas and the Everest. Plate tectonics theory is the last one that explains the formation of fall mountains. One is when oceanic plates meet another one. One oceanic plate meets another, or when we have the continental plates meeting the oceanic plates. The sediments under the sea. One, we need to be talking of an oceanic plate here versus a continental plate or versus another oceanic plate. The sediments, there are normally a lot of sediments under the ocean. Now, these sediments are compressed to form the fold mountains. The example is the Alps. Yes, we've talked of those four theories that try to explain the formation of fold mountains. But one that is frequently asked is the construction. I frequently asked is the contraction, no, it's the contraction. The one that borrows much on the plate tectonics. Other features that forms as the result of folding include escarpments. I've said the first one is folding. Number two is escarpments. Number three are depressions. Number four are ridges and valleys. Number five is the rolling plains. And number six, the basins or the plateaus. Plateaus, yes. I've said basins, intermontane basins. Number two, intermontane plateaus, rolling plains, the ridges and valleys, the depressions, escarpments, and fold mountains. Now, there is a big reason why I took some time to explain on the formation of fold mountains. We have the four theories. I know we are limited to time and many other things as occasioned by the mode of teaching, but I want to give you an advice. We have major features that are frequently asked in examinations. And the major feature there is the formation of fold mountain. Take your time, go through each, understand how fold mountains are formed. Number two is, there is a very simple question that can be framed this way. Apart from fold mountains, name any other features formed as a result of folding. Remember, this is where the intermontane basins come in. This is where the plains come in. This is where the depressions come in. Those are just but highlights, and you get very free marks. Now, the major one that you'll be asked to describe the formation is the formation of a fold mountain. Now, take your time, read, go through revision questions, and you will be able to understand. I think I've given you how exams normally come in that setting. Now, finally, and I think this is where we'll end our lesson today. Importance or the significance of folding. Now, this is where you need to listen, because this is an area that appears very easy to understand. But again, I will tell you from my experience that this is an area that you can easily lose your 2 marks. Remember, this is an area that we normally ask 3 and you get double marks, but surprisingly, very few of you gets the 2 marks because of the way we will always want you to bring out your points. Now, under this, we will always test 3 levels of understanding. You rather listen to me carefully. Any question that asks you, give the significance of faulting, give the significance of folding, give the significance of anything. We will always test 3 levels of understanding. Now listen to me. I'll give an example of a point and describe how the 3 levels of understanding comes in. Now, like the first point, I will say, fold mountains leads to the formation of beautiful sceneries. That is the first level of understanding. Fold mountains leads to the formation of beautiful sceneries. Give an example of these beautiful sceneries. You can give the example of the escarpment. They are beautiful, by the way. You can give the example of the intermountain basins. That is, those are beautiful sceneries. You can give the example of Atlas. Even me, I even want, I'm also dreaming of one time visiting the Atlas, the Himalayas, the Everest, the Andes, and there's so many mountains that exist, the fold mountains. Those are beautiful sceneries, and give an example of one. You can say the fold mountains. That is the first level of understanding. And by the way, you'll not score any points by saying that. Now go to the second level of understanding. These beautiful sceneries attract tourists. The first level of understanding is the first part. Fold mountains lead to the formation of beautiful sceneries like blah, blah, blah. You give an example of the sceneries. That is the first level of understanding, and no mark for saying that. The second part is give a justification, give a description, an expoundment on what you are talking about. These beautiful sceneries are tourist attraction sites. That is level 2 of understanding, and no mark for it. Now, for you to earn the mark, the 2 marks, is by giving us the last point. These tourist attraction sites, they attract tourists which bring in foreign exchange. No mark for it again. One, the first level of understanding is fold mountains lead to the formation of beautiful sceneries. The second level of understanding is this. I've said the first level of understanding is fold mountains leads to the formation of beautiful sceneries. Level 2, these sceneries attract tourists. Level 3, these tourists bring foreign exchange. Level 4, the money and the foreign exchange can be used in other sectors of the economy, like the infrastructure and many other areas, education and many other things. No, you have the 4 levels of understanding, and that point, when you give such a point, believe me, nobody will ever mark it wrong. But if you give the 2 levels of understanding, and in some instances, give 3, some areas you may not really get it. But if you give 4 levels of understanding, no one will mark it wrong. So at all times, when you are asked to give significance of folding, volcanicity, whichever, rocks, yes, everything, you always need to bring in the 4 or the 3, at least 3. And because you are from 2, we will always say, at least 3 levels of understanding. But later in life, when you will be in Form 4, Form 3, we will always mark the 4 levels of understanding. James, is it clear? Yes? Yes.
Yes.
Now, I will also try to give another example so that it is very clear to all of us. We all understand that as a result of the fall mountain, we will have the leeward side and we will have the windward side. Don't make this mistake. Somebody can, student somewhere, not from Mang'u, can say, they can give out this point. Fall mountains leads to the formation of fall mountains can we have adequate, I'm just trying to paraphrase, maybe a student from some school somewhere, and he's just trying to fumble out his words on how he can score these 2 marks. And he will say, the formation of fall mountains leads to rainfall. This mountain can attract rainfall. The rainfall can be used in, the crops can really flourish in such environment, and the crops can be sold to do 1 or 2 things. Now, that student will not score because we have the leeward side of the mountain and we have the windward side of the mountain. Always specify. It is very wrong for you to say that the entire mountain will receive rainfall. It is very wrong. As a good student of geography, you will always tell us the windward side of the mountain. Specify that. The windward side of the mountain will receive rainfall, adequate rainfall, which crops can be grown in, and therefore it earns the country a lot of, you can export this. We export tea, we export coffee, we export many things. It can earn the country foreign exchange. It can be used in improving other sectors of the economy. Now, my point is to be specific in your points. You need to be specific. You need to be specific. Another one is fall mountains. We all know that these can be catchment areas because we have a mountain, and specifically, and I'm repeating again, not all part of the mountain can be a catchment area. It is only the windward side of the mountain. Now, these windward side of the mountain can be catchment areas, which can be sources of rivers. Again, that is not good to earn your mark. You need to go by describing to us how important are these rivers to the economy. We can use it in irrigation. We can use it in trying to generate power and many others. Tell us those details. If you become mean with your words, then I can tell you that you will get it wrong. Mine is just but to guide you on how you should present your answers. We all understand we come from a prestigious school, that we need to be presenting our answers in a different way from other schools. The way you present, your Mang'u student present the answers should be different from how other people present the answers. And that is why we are just trying to guide you on some areas that you need to be careful on. Those are many things that we've learned. I will want to thank all of you for taking your time and being patient and listening to what I've presented. But again, that is not enough. Go through your time, take your time, go through the work, pole pole. And you will be able to understand all those things in a bigger way. Now, Corona pandemic presents to us a very unique opportunity. It appears to many of us that is something we can, I want to take it as a blessing in disguise. Those of us who had not understood some concepts, it is time for you to catch up with the rest. Come January, you should be talking of this. We should be in the same wavelength. When I talk of this one, everybody should be in the same wavelength of understanding on many things. Those things that you do not understand, take this time to go through those works. Otherwise, I really want to thank everyone. Take care, maintain social distance, wash your hands, and wear masks.
Yes, excuse me, sir.
Yes.
When are we going to receive our geography papers?
Your papers. What happened was when you sent me your papers, I printed them out and marked it because it was very difficult to mark it online. Some things were not legible, and it really presented a problem to me. So what I decided was I printed, then I marked it the normal way we normally do it. So it is, I don't know how best I can return the papers. I don't know how best I can do that.
Excuse me, teacher.
Yes?
Can you be asked to draw a fold mountain and name it?
No, the only thing that you can be asked is you can be asked to name parts of a fold, not a full mountain. It is a little bit difficult for you to be asked that. Parts of a fold, that is the crest, the trough, those things, yes. Any other question?
Excuse me, Chair.
Yes.
Can you be asked the similarities between the continental rift and the plate tectonics theory?
Yes, there is a possibility, but I think the similarities are very few. We only have a lot of differences. So yes, but not really.
Okay.
But I think what I can say is if you understand the two theories very well, whichever question that can be presented, you'll find it so easy to explain.
Okay.
Any other question? Yes, sir.
When you are naming the parts of a fall,
Yes.
The crest and trough same as anticline and syncline.
Sorry?
The crest and trough, are they same as anticline and syncline?
Be audible enough. I cannot get you clearly.
When naming the parts of a fall, are the
Yes.
crest and trough same as anticline and syncline?
Now I've said the lowest part of the trough is the syncline. That lowest part, hapo chini kabisa. Okay, the entire of it is the trough, but the lowest trough of the syncline is the lowest part of the trough is the syncline. Am I really clear?
Not really.
I've said you can just sketch a trough. Then that lowest point, hapo chini kabisa, is what is referred to as the syncline. But the entire of it is the trough. The whole of it is the trough. But that point where it is the lowest part of the trough is what is referred to as the syncline.
Okay.
Same applies with the anticline. It is the uppermost part of the crest. Yes.
Yes, thank you.
It says that the trough is the lowest part of the syncline.
Now I've said we have the trough, which is wider, the whole thing hapo chini. Lakini chini yake kabisa, the lowest part is the syncline.
Okay.
Yes.
Okay.
Excuse me, Chair.
Yes.
You said Alfred Wegener's book, was it written in 1912 or 1915?
It was of 1912.
I read in certificate geography and it says it's in 1915.
I think it is in 1912. It was 1908. It was later developed in 1912, and the whole thing that Wegener talked about was of 1912, the origin of continents. I think we should stick with it. But those are historical things, and nobody will bother looking at it. That is history. That is not geography. What Wegener talked about is what is geography.
Thank you.
Yes, thank you. Any other question? So otherwise, we can end the lesson. Let's meet next week. Thank you.